Okay, in the previous video, we introduced Hess's law, and we did a problem. So we have one additional problem to do, which is acetic acid is contained in vinegar, and if acetic acid was formed from its elements according to the following reaction: 2 carbons specified as graphite. As I said in the last problem, carbon comes, the most two common forms that we know of are graphite and diamond, so it has to specify which form it is. Plus 2 hydrogen plus an oxygen goes to form ethanol, CH3O, CH3COOH. And so we want to find the enthalpy change for that based on the following reactions. Because the problem is the fact that while we could do this reaction, there are several different products that could be formed here. So we don't know that this would be the particular product that we're looking at. But if we burn ethanol and oxygen, we get carbon dioxide plus water, and we have a negative 874. If we burn graphite and oxygen, we get carbon dioxide, and if we react hydrogen and oxygen together, we get water. So the criteria, we have to look at the criteria and select which one are we going to look at. So the two criteria are that it must be in the unknown equation, which this is the unknown up here, but not be, do this color-coded, not in any other equation. Down here, okay? So we're going to go through each reaction one at a time. We have ethanol. Ethanol is up here, so it meets the first criteria. We have oxygen and oxygen, so we have that. Carbon dioxide is not up here, so it doesn't meet the first criteria, and water is not up here, so it doesn't meet the first criteria. So these two elements, or these two substances here, ethanol and oxygen, meet the first criteria, but we need one that meets both criteria. So now I'm going to look down below. Does ethanol appear anywhere else? And the answer is no, so this one also meets the second one. If and for chance I have two that meet the same criteria, both criteria, then it doesn't matter which one I use. Okay, I've never come across one that could be the possibility, but we'll see. And the other one is oxygen. Well, oxygen's here and here, so this one does not meet the criteria for number 2. So we are going to use the ethanol here. Okay, so then the question becomes, how do I make this ethanol look like that ethanol? Okay, and it needs to be reversed, because here it's on the left or a reactant, here it's on the right or a product, so it needs to be reversed. But the coefficient here is 1 and the coefficient there is 1, so all I need to do is reverse this one. Okay, so by reversing it means I write my products first, so I have 2 CO2s, I'm not going to worry about writing the states down, plus 2 waters goes to form the CH3COOH plus 2 oxygen. So I didn't change any coefficients because I didn't need to multiply or divide. All I did was take the products, the things on the right hand side, and make them left, things that were on the left, and make them on the right. But when I do that, my delta H becomes a positive, and I write it down just because of the fact I want to emphasize it, 874 kilojoules. Okay, of course you don't have to have a positive sign there. Okay, so I'm going to erase this, and this, okay? And we're going to go to our second equation, okay? So for our second equation, we have graphite. Graphite does appear, it's up here, so it meets the first criteria. I'm going to go through the criteria. Oxygen, we know, is already there. Carbon dioxide is not there. So now those two meet the first criteria. What meets the second criteria? And carbon as graphite does. Oops, I hit the eraser button. Oxygen does not, so I'm going to erase that one. So I'm going to use carbon as graphite. Now, how do I make this carbon look like that carbon? This is on the left side of the reaction arrow. This is on the left-hand side of the reaction arrow, so I don't need to reverse it. This, however, has a coefficient of 2. This has a coefficient of 1, so I'm going to multiply by 2. So I'm going to have 2 carbons plus 2 oxygens goes to form 2 carbon dioxides, and then my delta H becomes a negative 394 times 2 to equal a negative 788 kilojoules. And yes, I'm working really hard to keep the arrows aligned and to keep these values over here aligned. So that is intentional. Okay. All right. Now let's go through and erase that so that my top doesn't get too crowded. Go back to blue. Okay. I have hydrogen. Hydrogen is up here, so it's there. I have oxygen is up here. Water is not up there. So these two meet the first criteria in the fact that it's in the unknown equation. Go back to my green. And hydrogen, we haven't seen it yet, so it's not any other equations. Oxygen we've eliminated every time because it's here and here. So we're going to use the hydrogen for our comparison. Okay. So again, I want to look at what side of the reaction it's on. Here it's on the left-hand side, or the reactant side of the reaction. Up here it's on the left reactant side, so I do not need to reverse. Here the coefficient is 2, here the coefficient is 1, so again I'm going to times 2. So I do that to the entire equation. So I have 2 hydrogens plus 2 times 1/2 is just 1 oxygen, and 2 waters. And then also multiply my delta H by 2, so a negative 286 times 2 gives me a negative 572 kilojoules. Okay. Now remember, you don't have to do this next stage. I suggest doing it because it'll let you know if you have a check or not. I have 2 carbon dioxides and 2 carbon dioxides, so here and here. I have 2 waters and 2 waters, so there. Carbon does not appear over here anywhere. I have 2 oxygens and 2 oxygens, so those cancel out. And yes, I do have another oxygen down here, but as long as they equal, they cancel. 2 hydrogens are nowhere else, and an oxygen is nowhere else. So basically, I then write down whatever's left. So I have 2 carbons plus 2 hydrogens plus 2 oxygens goes to form CH3, COOH. That's gone, that's gone, that's gone, so there's nothing else on the product side. So now I want to look 2 carbons, 2 carbons, 2 hydrogens, 2 hydrogens, and, did I make a mistake again? Oh, I did. I don't know why I wrote down this oxygen. Again, see, this is where you catch your mistakes. I canceled out my 2 oxygens. This is only 1 oxygen, so this should not be 2. But see, it makes me go back and make sure what I have done down here is correct. Oxygen, oxygen, methanol, and methanol. Okay? And so now I want to add up. So 874. It's either minus or plus a negative 788 plus a negative 572. And when I do that, I make a minus 486 kilojoules. And so that's the actual answer. So this part you have to do over here. This part is just a good check to make sure that you've multiplied and everything right and don't have any mistakes, which I had one, but it was right here, not in doing the problem. And so that is the end of this video.